Okay, and again, just one last time, if you guys haven't said something in the chat, please say something in the chat. And I really want to encourage you guys, like what Chase said. Oh, Kenzie said I don't have. Kenzie, did you get the link to the warm up? If you guys, thank you, Kenzie. If you guys have not put something in the chat, please do. And I would really encourage you guys, just like Chase, to share out what you did. I'm gonna send out a form to see if you guys want to get together virtually coming up. And also if you guys want to connect with each other, maybe share phone numbers or Snapchats or something. I don't know how many of you guys are on Instagram. I don't commit to Snapchat, but I do commit to Instagram. Okay. All right, what do we got to talk about? I'm going to start right here. BVLA high school. Okay. So we met as a school, the staff, and we said that we are going to do some of the assessments at the BVLA high school. And this is also coming down, like the district says, hey, you guys have to do this. Oh, I should not make fun of my district. I'm sorry, they employ me. The district said, hey, you guys need to do this. So what I need you guys to make sure right now, everybody needs to make sure that when you go to classroom.google.com, that you have the class, and of our school, I think we're at 92%. So we're missing a few people, but the majority of you guys are here. But right here, BVLA 2021 high school. Okay. You guys need to have this class, and I'm going to copy down the link and put it in the chat. But you guys need to make sure you have this class, okay? Because the English assessment that's coming up this week is going to be here. And I think everybody's going to do it, but especially if you have Mr. Tommy, I'm sorry, Mr. Abshire, then you're going to do this. And then in the classwork yesterday, not yesterday, yesterday was Sunday, Friday, I put in world history ingenuity notes. And so you guys can click on this link, and here, if most of you guys are taking world history, you guys can click and find the little section that, like, this is the Ming Dynasty, and you guys see how they organize the notes. And so, when you guys watch the videos, if you can fill in these notes, and you can obviously, download these, make a copy of these, and then download them and write on them with Cami. This is what you can use as a resource for your quizzes and for your tests. Okay. And so these are there, and they're not fully 100% complete, but they will be. All right. So that was on the Google Classroom right there for BVLA. Okay. And we're going to put more resources right there for you also. So right now, I want you guys to make sure that you have access to this. Okay. And I put the link down in the chat. All right. So that's number one. Okay. Let me give you some feedback on the assignment. So I was grading one of the postulates. I think it was the line segment addition postulate, and you guys wrote down the answer. So you did all the questions, or you did enough questions for me, and you said, number 1 is 12, number 2 is 9, number 6 is 15, number, whatever. And if you only wrote down the numbers, like, let me give you an example. Let me go to the classroom. There are some problems where only writing down the number to me makes sense because it's simple arithmetic. And I wish you'd show your work, but I'm like, you know what? This is a high school sophomore math class, and I think we can trust each other for that. It would be as algebra 2. Come on, Mr. Brooks. Let's say like the Engels assignments, Engel addition postulates, Engel bisector. Well, let me go back to the line segment addition postulate, okay? So like 1 through 6, even maybe 1 through 8. I don't think you should show, I'm not going to be picky about showing work for that. Okay, like I said, I wish you would, but it's not terrible. If you look at this page though, 11 through 14, or if you tried 15 through 18, that I absolutely would want to see how you set up the equation, because a huge part of this class is, are you setting up the equations correctly? Okay, so when you tell me a number, I'm not going through and I'm not checking, and maybe you are going back and you're checking the answer. But I want to see how you set it up. Okay, and there's even some of these, there's different ways you can set it up, but I want to see at least how you set up the equation. And then if you want to work the equation on paper, you can, then great. And if you don't, then you've shown me your thinking about how you set it up. Now, do you have to show that for all of them? No. A lot of these worksheets follow the same pattern, right? And so it's like this part plus this part equals the total, for example, or this half equals that half, and you set up the two expressions on either side of the equal sign. So you don't have to, I'm not going to harp on you showing your equations for all the problems, but when I say attach a work sample, I mean like pick like 2 or 3, one that follows, one from each pattern set, and show me that you know how to set up the equation. Okay. Can you guys type in the text box if you understand what I'm talking about? Can you say, yes, that makes sense, or no, that doesn't make sense? Because I returned a lot of scores that were not full, and I felt bad because I felt like I was picking on people. But if I just see a number, I'm like, okay, I have no idea. I would rather you set it up incorrectly so I can give you the feedback than you just putting down an answer where I'm like, I have no idea what this kid did. Okay, and again, you don't have to do 100% of the worksheet for 100% credit, and you don't have to show work for 100% of the worksheet. A work sample, let me use the word work sample. Pick a couple of the problems, not up here where it's just the simple arithmetic, but this is where we need to be at right here. Okay. 11 through 14. This is where I want to see that you know how to set up the equation, and especially the word problems, like 11 through 12. Any type of picture would be good where you understand what it's saying. Okay. I do want to talk about number 15 because I tried to do this early in the morning and I was like, oh my God, I just don't want to take up too much time while I figure out, because like anybody, I have to think too. And thinking on screen is hard, right? Can I get an amen? Thank you, Damien. You're fine. So for this one, what I ended up doing, and I said, we're solving for CD. So what does CD equal to? And let me get rid of that already because that's going to be nasty. So what I said was CD is equal to 27 plus X minus 3X plus 47. And then this is an expression. And so what do I mean by expression? I mean that it's in terms of X, right? Because 3X plus 47, you can't combine those. So this whole expression right here, this is the value of this segment. And so I have to put this in parentheses, okay? So what does that mean? That means that I'm going to distribute the -1. This is like saying -1 right here. So I'm going to, when I simplify this, I'm going to distribute that, okay? All right, now, that's what CD is equal to. CD is equal to 3X plus 47, 27 plus X minus 3X plus 47. And that comes from the postulate that the whole thing is equal to part 1 plus part 2. Okay, but I can't solve for CD there because I have a variable. So I'm just going to get a variable back, okay? But CD is also equal to X plus 26 minus 10. Like right here, it's all of this minus 10. So it's X plus 26 minus 10. Okay, now I don't have to put X plus 26 into parentheses. I could, like this. I could write it like this. That's perfectly fine. All right, because it's an expression. I want to make sure you guys understand the vocab here. And it's very easy for us not to appreciate that x plus 26 is an expression. Okay, you're expressing a number in terms of x, and this is going to confuse everybody on the test. But x plus 26 is a number. It is. It's a binomial. It's a two-part number, but it's a number. Okay. Now, up top on this one, I have to write this in parentheses. I have to, because it's minus. I'm subtracting it. Okay. And you're going to see how that works out. But right here, because I'm adding it, I don't necessarily have to put it in parentheses. When I combine like terms, it'll just make sense as it is. Okay. All right. Are we good? Everybody good with that? Now, why have I written this in two parts? Because if you just look at the top, you can't solve for CD as a number. You can solve it as expression. And if you look at the bottom, you can't solve CD as a number. You can only solve it as an expression. But you can put those together to form one equation where you can solve it. So if CD is equal to this and CD is equal to this, then it would make sense that this is equal to this, since they're both CD, right? You guys tell me yes or no if you're following me. So 27 plus x minus 3x plus 47 is equal to x plus 26 plus 10. Okay, I'm going to switch over to a brightly colored thing right here. Oh, there we go. Okay, all right. Is that better? Is that better than the red? Can I find a better place right here? No, I can't. Okay. So this we can do. There's, what is there? There's distributive property right here. There's combined like terms right here. And then there's x on both sides. This was all stuff we took time for in foundations before we got going. So look right here. I've got to distribute this negative sign. I'm going to make it negative 3x and I'm going to make it positive 47. Was it positive 47? Look, I already wrote it down wrong. This is positive 47 right here. Hey, shoot. All right. Yeah, that makes sense. That happened. Okay. Okay, so one thing real quick, guys. I wrote this ended up being written down where this was plus 47. So you see how this is plus 47 up here? All right, but I'm gonna go with it. All right, so 27 plus x minus 3x. And then this turns into now negative 47. Okay, so again, it's plus 47. I wrote this negative 47 down wrong right here. And God darn it, if it's not taking me off where I want to be, is equal to, I'm going to combine this. 26 plus 10 is 36. Okay. All right, and then so we can combine up here too. We can say 27 minus 47 is negative 20. And then x minus 3x is minus 2x. And then this is equal to x plus 36. And look, it's already getting messed up. And this is why I like the drawing tool. Okay, and then we can solve this. Now it'll come out that x equals a negative number, right? So when you guys do this, it'll be x equals a negative number. And is x allowed to be a negative number right here? Yes, because ultimately, you'll have a negative number plus a number, so the value will turn out positive. So it's okay if x is a negative number on all these, okay? All right, I wanted to take a little bit of time, not too much, to go over number 15. I think number 15 is like for those math geniuses out there. And there's somebody in the room that got that. I know there's a few people in the room that got number 15. But I mean, it really takes a lot of thinking, like, okay, you know, how do I find CD? Well, I know that CD is equal to that, and I know CD is equal to that. I mean, that's a lot. That's a lot. Okay. And I wouldn't feel bad if you didn't get it at all. But I hope that everybody took time to look at the answer key. Remember, the answer key is provided to you. And I hope everybody took time to look at the answer key to see how you would do it. Okay. All right, let's get off that. And then the next thing is test corrections. Test corrections were posted. It was my intention to go over the test today and put that out there. I'm gonna think a little bit more about releasing the key and all that, and that will be out in a video by today or early tomorrow. Okay, so the test corrections are there, so you can do the test corrections. Try to do them based on the learning targets that I gave you. I don't think I've gotten all the tests in yet, but the majority of people that turned them in did really well. I mean, it's very impressive. But let's on Wednesday we will talk about the test, you know, if everybody's in or not. Okay. At some point, probably Friday, I'm gonna say, like, guys, everything from unit 1 should be turned in. Okay, we're on unit 2 now. I don't want you to turn in unit 1 too late. So I'm gonna make an announcement, but probably by Friday, I would like you guys to have all your unit 1 Delta math in, and I would like to have all your unit 1 assignments in. And so I can have those graded and we can move on. Okay. I don't want to go back in November and go back to August assignments grading. That would be a lot of work for me. Okay, so if that's a problem, let me know. All right, if you guys, and we have people in here that have gone through some rough stuff. But if you're thinking like, hey, Mr. Brooks, you know, I'm struggling with this and I need some help on this assignment, please let me know. Okay. All right. Lesson plans. Lesson plans for today were right here. And notice I merged these two cells. Hope you guys know how to use all these insert grids and everything, the tables. But Monday and Tuesday, today and tomorrow, are you have this to do. It's chunked as 2 days. You can do some of it today, you can do some of it tomorrow, you can do all of it today, you can do all of it tomorrow. Okay. At the end of the week, is these 2 assignments right here in Google Classroom. And these 2 assignments, you can do it today, tomorrow, Wednesday, Thursday, Friday. But by Friday, I'd like you to have these done, and where you can go back and look at your scores and where you can ask questions on them. Okay. Now, the next thing we're going to do right here is going to be line partitioning. And I think that there's some line partitioning on this assignment, and we haven't done line partitioning yet. So if you're getting into line partitioning on this assignment before we cover it on Wednesday, then don't get frustrated. Okay. I will go over line partitioning with you, I promise. Okay. Line partitioning is probably the toughest thing we're going to do in the unit. And it is formula based. Okay. All right. So here's a good video I posted on how to do these, but I'm going to do it right here. And then also somebody asked a question already about, I can't get this graphing to work. And so I posted a video of me doing some of the problems right there for you, so you have those resources. Okay, so let's go to our unit 2 and let's talk about doing these a little bit. So the learning targets are midpoint. This is the midpoint formula right here. Okay, so there's a video for you too. The learning targets for today and tomorrow is midpoint and distance formula. Okay, and these are not related, but they're formulas and they're fairly easy and benign. So I think we can do them together. But there's a cheer for the midpoint formula, and a student taught me this from middle school, and I love it. And you guys probably did this in middle school too, but they say, midpoint, midpoint, what do we do? Add them together, divide by 2. So every time, I hope that you do these assignments, you're like, midpoint, 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 what do we do? Add them together, divide by 2. It's that easy. And I think about taking the average, right? If you have 0.1 on one end and 0.2 on the other end, then the middle is just the average. So just add them together and divide by 2, just like taking the average, okay? And now this is X and this is Y, so you have to kind of do the same little formula twice, all right? So let's go to deltamath.com and kind of do one of each of these, all right? That is not how you spell deltamath.com. Let me done in 10 minutes here. Okay, so here's our first question right here. All right. So it gives me 2 points. It says 10, 6, and 6, 10. And what's the midpoint? The midpoint. What do we do? So take the x's and add the x's together. All right. Add them together, divide by 2. That is 1 point right here. So, just remember, x comes first, y comes second. X, then y. And you need to have a good working knowledge that, this is a coordinate point, this is the x. And so, where's 10, 6? So 10 along the x and 6 up here. So here's this first point, 10, 6, and the other one 6, 10. So it'd be 6 and then 10. So it'd be like right here. It'd be something like that. So what we're looking for is something like right there. Okay. And you can use some mental math to kind of check. Like if you get a number outside between 10 and 6, then you should be like, oh, something happened. All right. So 10 plus 6 is 16. 16 divided by 2 is 8. And 8 is between 10 and 6. And you can almost kind of realize right now that, hey, I can kind of rationalize that, right? I mean, what's halfway between 10 and 6? Well, halfway is 8. So y would be 6 plus 10, which as it turns out, when you divide by 2, that's also 16 divided by 2. So it's also 8. And such a weird thing for it to come out like that, but that's okay. So our answer is going to be, as a point in parentheses, 8, 8. Okay. And then, they drew what I drew right there. Okay. All right. Questions on midpoint. That makes sense? Did anybody already do this? Okay. Now there's a question on the test that looks like this. Okay. And so what is this saying? It says, imagine you have a line and it's AB. So AB is line. And there's a point M, the midpoint. And I'm going to give you A. A is 3, -6. And I'm going to give you the midpoint. The midpoint is 5, -5. And it says, what's the coordinates for B? So here I'm going to use the midpoint formula, but I'm not going to use it as equals to the answer, but I have to plug X in, right? So if you remember, it's a number plus a number divided by 2. So it'd be the X of A. So of point A, the X value is 3. So it'd be 3 plus B right here. So this would be like X comma Y, where I need to solve for that. So now I'm going to solve for that. And what is that equal to? Well, the midpoint is 5, right? Okay, I'm going to pause right there. Does this make sense where I'm plugging this in? Can you guys give me a yes or no? Type something on the keyboard. Let me know you're still alive. Is anyone going to eat the ice cream in the freezer before their mom gets home? Okay. All right. Now, again, Now, remember what we talked about? This is an expression, right? Going back to this expression, this is one number. 3 plus x is one number. That should sound foreign to at least half of you. And I know you guys are good mathematicians, but I think it should sound foreign to at least half. Half of you guys should now be like, oh, my math teacher is going blah, blah, blah. Okay, 3 plus x is one number, all right? So when we did two-step equations to solve for x, we said do PEMDAS backwards. And so we always said add and subtract first. Okay, but this is one number right here, so you can't split this up. So you're not going to add and subtract first. You're not going to subtract 3 first. Okay. You believe it or not, this is one number divided by 2. So the inverse operation is times 2. And this is my one number down here now. Okay, so all of August for foundations, I said do PEMDAS backwards. When we solve, you're going to add and subtract two-step problems first. And here I am saying, okay, it looks like I broke the rule. It looks like I'm not doing PEMDAS first. But the reason I'm sorry, PEMDAS in reverse. The reason I'm not doing that is because this is one number. This is an expression. 3 plus x is one number. It's not 2. Okay. Can you guys tell me if that makes sense or not? And you can say it doesn't make sense at all. And I believe you, because if I was in high school, I would be like, there's 2 numbers there, Mr. Brooks. And so minus 3, this is 7. So x is 7. Okay. And then you do the same thing for y. Y would be -6 plus x is over 2 is equal to -5. All right, so times 2 is -10. I'm going to type this in -7. So times 2 is -10 and plus 6. So right, -6 plus 6 is -4 as -10 plus 6 is -4. So -4. So -7, -4. No, it's 7, -4. Okay, so 7, -4. Clear all drawings. So 7, -4. Okay, all right. So you'll see they did it the same way right there. Okay. Now, hopefully, I know some of you guys heard something new today. That is an expression, that is one number. Reminder of reverse PEMDAS. I believe everybody here probably got something if you were paying attention. So that's some good math. Okay. All right. Now, distance formula real quick. Okay. Oh, does anybody have any questions on that? Does anybody have any question, but they don't want to speak up, so they're going to come back later, which is fine. Okay. All right. So I gotta figure out how to get back here. All right. So the next one is the distance formula. Assignments. There we go. Okay. And what is the distance formula? Here it is. Okay. The distance formula is you find the distance x2 minus x1, and the 2 is a subscript, sub meaning below. A subscript, remember the exponent is a superscript. This is a distance, and this is a distance, and you're going to square them and divide by 2. And what this should look like is this should look like Pythagorean theorem. This is rewritten Pythagorean theorem. The way you find the diagonal of a triangle is the Pythagorean theorem. And so you can make a triangle, and you can use Pythagorean theorem to find the distance between 2 points. And that's what it is. Okay. All right. So this actually walks you through it. So coordinate distance graphically, What you do on this is you click and drag. And when I click, I'm not going to hold down the button. I'm just going to click and then release, and then click and then release. And it comes up and says, you may now answer the question. Okay, thank you. So what's leg 1 and leg 2? So a triangle has 2 legs and a hypotenuse. Let me back up. A right triangle has 2 legs and a hypotenuse. Okay. All these are going to be right triangles. So it doesn't matter which one's leg and leg 2. If you count it this way first, I think it wants this leg. So if you pull down, then that better be leg 1. And if you pull across, that better be, if you pull across first, that better be leg 1. Okay. So, and then you count, what's the distance between here? Well, if you remember the distance formula, it was just x2 minus x1 or y2 minus y1. So you're just, that's like counting, or you can think about the distance. So, you know, it'd be like 3 minus -6. Okay. Or you can count here, 1, 2, 3, and then 6. So that'd be 9. All right. And then right here, leg 2 would be across 1, 2, 3, or you can go from -9 to 4. So that'd be 5, right? 1, 2, 3, 4, 5. All right. Now this distance is positives. Okay, because anytime you count, it's positive. And it's always going to be positive. So let me show you this again. Let's say that you subtract these 2 points in your formula and you get a negative number. Will it ever be negative? Well, no, it won't be negative when you do it, because see this little exponent right here squared? You're going to square both sides. I mean, sorry, you're going to square this number, and it, no matter what you get, it's going to be positive. If you get a positive number right here and you square it, you get a positive. If you get a negative number right here and you square it, you get a positive. So you'll never get a negative value right here. Now, and this is plus. So like I just counted the y first, right? I just counted this. And does it matter? Like this is the distance y plus the distance x. Well, no, this is commutative. So that's why, I mean, when you guys do this delta math, you know, start thinking like, hey, you know, does it matter? Do I do the x first? Do I do the y first? It really doesn't matter. Okay, so you guys can use the distance formula right here and plug it in. If you want to do the distance formula, it's just, I'm sorry, it's just x. So that would be like -9 minus -4 squared plus -6 minus 3 squared. Okay, and you guys can do this distance formula for this just fine, or this is going to be Pythagorean theorem, which is pretty much the same thing. But basically you have 9 squared plus 5 squared, right? And then this becomes 81 plus 25. And then 81 plus 25. 81 plus 25. It's 106. 106. So the distance of this is equal to the square root of 106, not 106. The square root of 106. And that's, I helped a lot of people on like the kitchen task, the second part of the kitchen task, where my point was 106 is not the same thing as square root 106. 27 is not the same thing as square root 27. Okay, so, you know, keep in mind what you're doing with the distance formula. This is staying here the whole time. All right. Or, you know, this you're going to get this on the Pythagorean theorem. If you remember a squared plus b squared, you know, it'd be the same 81 plus 25 is equal to c squared. And then what do you do when you have 106 equals c squared? How do you cancel off the square? You square root. And then you get c equals, right? Okay, now I could type in square root 106 here, but I need to ask, can it be simplified? So I'm gonna take 106 and divide it by 4, and that's not gonna work. 106 and divide it by like 16. And I'm thinking it doesn't. So we're gonna find out. So square root 106. But I'm gonna ask if I can simplify it, I'm gonna simplify it, okay? And there you go. All right. Okay, and that's it. That's how to do it. All right. Okay, the time is 8:43. I'll just go over this person really quick. Oh, was there any questions? As I click off, are there any questions? I'm gonna stop recording.